So question 12 is really good because it uses a lot of hence, it uses a lot of manipulation of cis theta, so it's a nice one to do. Hopefully you can stop the video and not listen to a lot of what I have to say or fast forward bits and pieces, right? So you want to really try and solve it yourself and not just sort of listen and go, oh yeah, that's what I would have done. So try not to watch too much of this. So we've got cis theta is z and we want to prove this. So hopefully you didn't need me at all to actually substitute this in. So we've got cis theta to the n plus cis theta. We're going to pop that n upstairs, it becomes minus n. And now we can use de Moivre's theorem. Okay, so there's a 1, so it's 1 to the n. That doesn't really count for our modulus. And cis minus n theta. Now you sort of think, oh, can I simplify with adding these together? You could, but then they'd cancel out and that's no good. Look at what we're trying to get. Always look for your right hand side. So in order to have a cos n theta in there, we're going to replace our cis theta for that one with, that is cos n theta plus I sine n theta, and we'll do the same for this one. So that becomes cos negative n theta plus I sine negative n theta, and hopefully you've turned this off by now because you can see what's coming. We've got our cos n theta, writing it again, so it looks like we're doing a heap of work, but we're not really, because this is the bit that we're playing around with. We remember the property that cos negative theta is the same as cos theta because that's an even function, and so I can rewrite this as n theta, and along the same lines we know that sine of negative theta is negative sine theta, so this becomes minus I sine n theta, and hey presto, they will cancel out, right? They disappear and I'm left with cos n theta plus another cos n theta, so I get 2 cos n theta, which is exactly what we wanted. Okay, let's try the next one. Moving along, hence, explain why. So remember, when it's got hence, you must look at what you've done before and what's the connection that we can see here. Well, pretty clearly, I hope you're saying that, well, in this case, we've just got n is 1 and 1. So look at what you've got there. Okay, explain that when it's 1, that becomes 2 cos, and you actually have to say that, right? We have to say that n is 1, and therefore z to the 1 plus 1 over z to the 1 equals 2 cos, say 1 times theta, right? Because if you just say, oh yeah, it is 2 cos theta, we know it is. They gave it to you. So explain how you realize that that is the answer. Okay, so pretty nice there. Next one, use binomial theorem to expand, then simplify your result. So we get our favorite little friend here, Pascal. Remember our Pascal's triangle, 1, 3, 3, 1. So when I expand this, I know that is going to be that first one, z cubed, plus we're going to have 3 times, now the z is squared, but I'm timesing it by the next term here, which is 1 on z, and that's technically to the power of 1, plus 3 times now z cubed, z squared, this becomes z, but then we times 1 over z, and we take that to the power of 2, plus 1 lot of z is now to the 0, and we've got 1 over z cubed, right? Don't forget, simplify. So we've got z cubed, z squared divided by z gives me plus 3z. 1, you square the top and the bottom, 1 squared is 1 over z squared. So this now becomes 3 over z. And last but not least, we've got 1 over z cubed. So that's our beautiful binomial expansion, going along nicely. Okay, so here's where it might get a little bit tricky. So you should have done all of that first part, never really had to listen to me much at all. We've now got this one, hence show that, cos cubed is equal to, sorry about that noise, cos cubed is equal to this. You go, so where have we got cos cubed? We've got something cubed here, and we've also got these ones up here. So if we take a look, if we just start off with cos cubed, we're not really sure where we're going to get our 1/4 and whatever from, and all up here we've got our 2 cos and 2 cos. So we want to end up with some 2 coses in there. So let's try and use this one, because you can see that this cubed relates to this one. So we're going to have a play, and let's start with, if we take 2 cos theta cubed, then using this bit up here, right, we can say that this would be the same as z plus 1 over z cubed. So that's from, I think we called this part 2, using part 2, and then using part 3, we can expand this, right? This is this bit here. We can expand this to be z cubed plus 3z plus 3 over z now plus 1 over z cubed. But you're going, where are the causes? Well, if I can group my z cubed with my 1 over z cubed there, because if we're looking at our very first bit that we proved here, if I had z cubed plus 1 over z cubed, that would become 2 cos 3 cubed. Okay, and then when I've used that, what I've got left is I've got, oh, we don't need an equals, I've got this plus 3z plus 3 over z, and that's not really helpful unless I pull out that 3, because then I've got this. Okay, so what I can now do is have these two little separate bits. We've got z cubed plus 1 over z cubed, and then I've got 3 bracket z plus 1 over z. Now if we scroll back up, right at the beginning, we've got that zn plus 1 over zn equals 2 cos n theta. So our n is, in this case, is 3. So I can now replace this with 2 cos 3 theta. And here I've got 3 times z plus 1 over z. If we go back up, and where was it here? Z plus 1 over z, I can replace that with 2 cos theta. And we seem pretty happy with ourselves. Well, I know I am. So 3 times, what was it? 2 cos theta. You go, yay, that's looking really good. And I look at what I'm meant to prove, and alas, it is not that. But remember, what you've got here was 2 cos cubed, and we only had cos cubed. When we're cubing something, we cube everything that's in the bracket. So technically what we've got here is 8 cos cubed theta equals this. So to get rid of my times 8, we're going to divide, and I think you can see what happens there, that hopefully we end up with the same. So you can finish that bit. You know, we've got this last bit here. We've got show the exact value of cos cubed of this is this expression here. So using what we just had before, okay, they've just given us this bit here, right, cos cubed, because once again they've gone hence, so you must use what we've just had there. We can say that theta, right, is 13 pi on 12. So start getting used to actually writing down your thoughts. So we can say, using the previous question, which I believe was part 4 there. So using that, we can say that cos cubed of 13 pi on 12, right, we're going to sub that into, so it was 1/4, just go back up and have a look so you know what's going on. So it's 1/4 cos times 3 theta, so it'll be 3 times 13 pi on 12 plus 3/4 cos 13 pi on 12. So we're just going to sub that straight in. So we end up with cos, so 1/4 cos of 3 times 13 pi on 12 plus 3/4 cos times 13 pi on 12. Just pop that. Okay, so just wrote that 3 and the 12 cancels to get 4, so 13 pi on 4. They gave us a hint over here, right? That bit there hinted that we can separate. So I hope you can see, I know it's hard with the yellow on white, but 13 pi on 12, we can break that up to be 9 plus 4. 9 plus 4 all over 12, all over 12, and that gives us ones that we know. So we've got 3 goes into 9 3 times and into 12 4 times, and this one becomes pi on 3. So these are now radians that we know exact values for cos theta and sin theta. If you want to have a think about it, you could have actually, if you wanted to, also tried 10 pi on 12 plus 2 pi on 12, but they've given us this hint. But you could also use this, because this now becomes 5 pi on 6 plus pi on 6, and that would work, sorry, not pi on 6, so 10 plus 3 gives you 13, that would be pi on 4. Silly me. Okay, and you could do that. But anyway, we're going to stick to the hint that they've given us, so this becomes 3 pi on 4 plus pi on 3. Okay, we want to simplify this a little bit. How can we do that? I mean, you can just go to your calculator and chuck it in there, but imagine if we didn't have our calculators. Do you agree that this is actually 2 pi, because 2 pi would be 8, so 8 pi on 4 is 2 pi. That leaves us with 5 pi on 4, so check that on your calculator there, right? So do you agree with me that 8 pi on 4 plus 5 pi on 4 is the same as your 13 pi on 4? And then this cancels down to 2 pi. And remember, when you're doing laps, this would mean that we've got 1/4 cos, that is just the same as 5 pi on 4. But again, you could rock your calculator out there. And then for this one, because we're showing, I want you to go and look up on your rules. Is there a rule that can help us simplify when we've got cos A plus B? And we should find that we've got cos A, cos B, plus sin A, sin B. So I'm going to leave it there, so you can use this, right? Your A would be the 3 pi on 4, your B would be your pi on 3, sub it in, and you are trying to fiddle around so we get to this. So let's see that you can do that. And then once you've established that sort of pattern, the next bit here, very similar to what we just did. So apply what we did with the first part there, part A and B. I'm going to pop the solutions on here. So again, I'd prefer it that you don't look at it. Try and do it by yourself, but they're here in a moment if you need them. So stop the video now. Okay, so try not to look at this. This is just if you get stuck, and hopefully you don't. So I didn't want to talk too much about this, but pretty straightforward, similar to what we just did before, same as what we did before. So pause it if you need to. Okay. So then we had to show this bit here. The first bit is pretty straightforward. We just replace. Okay, so we knew that sine cube theta we could replace with that. That's what we did in part B. This was what we did in part A. You expand, 3/4 times 1/4 is 3/4, etc., etc. You can follow that along. We're then looking at gathering your similar connection. So sine theta cos theta, right? Sine 3 theta cos theta. That actually hits this rule here. So I can simplify that. And then this one, I can see that I've got sine theta cos theta, but I want to use this rule here. So 2 sine theta cos theta equals sine 2 theta. But I don't have that 2 there. Sorry, that 2 there. So let's just make it a 2. So I've times by 2, but then I have to divide by 2. And then do the same with this, because I've got sine of something times cos of the same something. Again, I can use this rule. But I didn't have the 2, so I times 2, but then I divide by 2. Okay? So when I simplify that using this rule, you can look that up now. Okay, it's just a little bit of algebra now. So 2 sine theta cos theta are replaced with sine 2 theta, right? So that whole thing there, right? That bit there, we replace with sine 2 theta. Oops, sorry. And then I've got, don't know what happened there. And then we've got the 16 times 2 is 32, 9 still there. And then here, that's my, technically my sine of A, sine of B, right? Sine A, sine B. So we times sine A, sorry, and then we times it by 2. So that's what we get. 3 theta times 2 gives me the 6 theta. And then it's just a matter of gathering your like terms. Seeing that this rule comes up a fair bit, that when we've got the minus sign of a negative number, it's out the front of a negative angle, and there, that's done. Okay, so quite tricky, long-winded test question. You'd be wasting too much time. Anyway, that's 12. Hope that helps.